These are solutions for sections 4.1, 4.2 of written assignment. This was a function. We were asked to find the critical numbers. We differentiated. We set it equal to 0 because this function is always defined. Critical numbers will not come from g prime being undefined, so these are the critical numbers. Same question for the rational function. The top function prime is 1 times the denominator minus the numerator times the denominator prime, which is 2p, and the denominator squared, p squared plus 4 squared. Distribute negative 2p squared and positive 2p in descending order, combining like terms, negative p squared and plus 2p and plus 4. Factor out negative 1, we're left with p squared minus 2p minus 4. H prime of p is never undefined, but it equals 0, so we have to use the quadratic formula. This is not factorable. Negative b plus or minus b squared minus 4ac, so that's plus 16. So this is the square root of 20, which is 4 times 5, so the square root of 2 times the square root of 5. The square root of 4 times the square root of 5, which is 2. And then you simplify 2 over 2 plus or minus 2 the square root of 5 over 2. You separate in two fractions, or you factor out 2 to simplify. You cannot cross out this with this or just this with this. You either separate into two fractions. 2 over 2 will become 1, plus or minus 2 the square root of 5 over 2 is the square root of 5. So these are the critical numbers, only from h prime being 0. Same question here. I rearrange the function, multiplying, distributing x to negative 1/3 times x. Copy the base, add the exponents. Negative 1/3 plus 1 is positive 2/3. And then negative 2x to negative 1/3. So now here I also brought the cube root of x to the denominator, and I multiplied by the cube root of x. So this will be x to 2/3, and then minus 2 over the cube root of x. But this is the same thing with the cube root of x squared, this. So when you multiply by the cube root of x, the cube root of x times the cube root of x squared becomes x, and then minus 2 over the cube root of x. X cannot be 0. But the same thing here. So the function is the same thing. So h prime now. I will not differentiate this, but I will differentiate this. So 2/3 in front, x minus 2/3 minus 1 is negative 1/3, and then bring down negative 1/3 to positive 2/3. Negative 1/3 minus 1 is negative 4/3. I factor out 2/3 as well as x to negative 4/3, the smallest power of these two. And then negative 1/3 minus 4/3 is 1. So that's how I get the x here, and then plus 1. This goes to the denominator as the cube root of x to the 4th. So h prime of x is 0 only when x is negative 1, and that's the only critical number. Same thing here. We were asked to differentiate. So we differentiated. T prime is 1 times e to 4x, 4t, plus t, e to 4t prime is e to 4t times 4. So that is always defined. So critical numbers will be obtained only when this product is 0. But e to 4t will never be 0. So the only solution is negative 1/4. Here we're asked to study the function on a closed interval, and the interval was given to us 0 to 4. I start the table with f prime and the function, and I find the derivative as 54 minus 6x squared. Set it equal to 0 because it's always defined, and we get that x squared equals 9 plus or minus 3, but only when you take the square root, only 3 fits in 0 to 4. So I plugged in the original function 0 and I got 5, in the original function 3 and I got 113, in the original function I plugged in 4 and I got 93. So this is the absolute min, this is the absolute max, also relative or local, and this is nothing. Same question here. we differentiate the first function prime times the second one plus the first times the second one prime, e to x over 2 times 1/2 the inner function prime. I factor out e to x over 2 and I got 1 plus x over 2, but that changes into 2 plus x, right, in the numerator, or x plus 2 e to x over 2 divided by 2. When is this fraction 0? Only when the top is 0, when x equals -2. This function is an exponential function, it will never be 0. So the closed interval is between -3 and 1. The only critical number we found is -2, where the derivative is 0. Now I study the sign. I forgot to mention here, I study the sign of the derivative. I plug in the derivative 0 and I get positive, and if I plug in 4 here, I get a negative. And that's correct, increasing, decreasing. Same thing here. We study the sign, not of this and not of this. These are always positive. To the left of -2, this quantity is negative. To the right is positive. So this is typical for a local minimum. So this is nothing. This is the absolute and relative or local, and this is the absolute max. We plug in -3 in the function, -2 in the function, and 1 in the function to get these numbers. Next problem was asking us to show that it does not have critical numbers, or doesn't have max min. When you differentiate function 101 times x to 100 plus 51 x to 50 plus 1, this will always be positive because the power is even. This will always be positive, power is even. This is always greater than or equal to 0, so there are no critical, greater than 0, there are no critical numbers, and therefore no max min. Here we were asked to use Rolle's theorem. It's continuous, it's a polynomial function on this interval. It's differentiable everywhere, but definitely on this interval, open interval, as a polynomial function. I plugged in -2, I got -6. I plugged in 2, I got -6. All three conditions or hypotheses of Rolle's theorem are fulfilled. Therefore, there exists a C between the interval between -2 and 2 in the open interval -2 and 2, such that f prime of C is 0. We determine f prime, so I get 3x squared minus 4x minus 4. I said this is equal to 0. I have to use quadratic formula. The quadratic formula, -b plus or minus the square root of b squared minus, but there is another minus in here, so then plus 4ac, 3 times 16. So I took the square root from this. Oh, actually, I put in the calculator the whole thing, so I got 2 and -2/3. But 2 is not in the open interval, so it cannot be included. And c equals -2/3 is in -2 to 2, so this is the only critical number guaranteed. I'm sorry, the only c, the only value, a -2/3 guaranteed by Rolle's theorem. And the next one, the same. We were asked to use Rolle's theorem to find c guaranteed by Rolle's theorem, and it's continuous on the interval 1/2, 2, closed. It's differentiable at least on the open interval 1/2, 2, s functions that are continuous and differentiable on that interval. And f of 1/2 is 5/2 and f of 2 is 5/2, so all hypotheses are fulfilled. So then when you differentiate we get 1 minus 1 over x squared, or x squared minus 1 over x squared. The function is undefined at 0, but 0 is not in the interval, so there is no point in discussing that. But f prime is 0 when x equals 1 or -1, but only 1 is in interval 1/2, 2, -1 is not. So then c equals 1 is guaranteed by Rolle's theorem. The next two problems were on the mean value theorem. So the function is continuous on the closed interval and differentiable on the closed interval, on the open interval as a polynomial function, guaranteed. And by the mean value theorem, these are the hypotheses required. There exists a c in the open interval -2, 2, such that f prime of c equals f of 2 minus f of -2 divided by 2 minus -2. F of 2, f of -2 divided by 4. So f of 2 I got 4, f of -2 I got 0, f prime of x is 3x squared minus 3. So this could be either c or x, the same thing. So then c is plus or minus the square root of 4/3. Both work because they're both in the interval. So again, if you want to use c, you can use c here as c squared, same thing. And here's c. Same thing here, we're given this function, its derivative is -1 over x squared, it's continuous on 1, comma 3, differentiable on 1, comma 3, it's a rational function defined and continuous there, and differentiable there. Then by MVT there exists a c in the interval 1, comma 3 such that f prime of c equals f of 3 minus f of 3 minus f of 1 over 3 minus 1. The denominator is 2, f of 3 is 1/3, f of 1 is 1. So the numerator is -2/3, the denominator will be flipped. So because we divide two fractions, -1 over c squared equals -1 over 3. So you square both sides or flip or use proportions. So then, I'm sorry, not square, take the square root from both sides and you get plus or minus the square root of 3. But only c equals the square root of 3 is in the interval 1, comma 3. So that is the number guaranteed by the mean value theorem for this function.